Hello there, thank you for joining me again today on another repair video of a Marconi 2955A radio communications test set. I have two videos at the moment regarding the repair, component level repair of these. This is the first of two videos. The second video is about an hour long, which will be updated and put onto YouTube very shortly, so keep your eyes out for that. This particular test set is failing on a couple of tests, which when I've examined what the test failures are in the service manual, these all refer to no TX deviation or modulation, which essentially is a fault which I've found, and I'm going to show you what that fault is. It's the same electronic component that's failed in this than what's failed in the other video, which I'll be putting on YouTube shortly, which is on the RF board, one of the RF boards underneath, and it's an electrolytic capacitor, and I'll go into that very shortly. But basically these three tests here are testing FM deviation that's been received into the transmitter monitor side of the test set, and the AF level, if you like, that's discovered or discriminated off the FM carrier, the phase mod test and the FM test. Now, interestingly enough, it passes all on the AM tests, which are some of the earlier tests that it's done, which is passed on. So I've read the service manual, and basically the service manual makes reference to 110 kilohertz IF, which comes in to be processed. Now I'll just show you quickly, give you a quick rundown of the signal processing side. So when we transmit into the test set on the RF sockets on the top there, what happens is the signal is sent into a power divider, which is this unit here with the heat sink, which you can just see here. This is the heat sink of the RF power attenuator, which deals with the transmit RF signal as it comes in and attenuates it down, and that signal gets passed off to the underside of the unit, and it goes to several boards, one of which is this board here, which is obviously, I think it's AA2, yeah. Now AA2 is the frequency counter board, so the signal comes in from the attenuator, RF attenuator, which I've shown you on the other side. This does a frequency counting of the RF signals coming in across its entire frequency range. But if you look here, I'll just zoom in and try and get a bit of better light on it. The RF signal is also going via another 20 dB pad. So a portion of the signal gets sent to this board for frequency counting, another portion gets directed through this pad and across this link to this board here. Now this board is the actual Demod board. This deals with the signal down conversion, because we can't deal with demodulating a signal, the modulation from a signal at very high frequencies. The test set has to down convert the signal that's coming in from this frequency counter board. The RF signal has to be down converted into an IF, an intermediate frequency, before it's then passed off then to the demodulation or discrimination side to recover the audio from the signal. You transmit mod, for example, that's coming into the test set. So there is a local oscillator, which is here, and this generates a local oscillator frequency, and mixers then, and you can see a mixer down here in this area, that red toroidal transformer, that mixes with the signal coming in, which is your sampled signal from the transmitter you're measuring, and together it produces an intermediate frequency, which is fed out on these connectors. and one of the connectors goes to the very rear of a test set, which is called your IF out, and the other two go off to another board which I'm going to show in a moment, which is on the other side. And obviously once it's down converted, the signal, it can be fed off then for further processing and demodulation. Now this board's fine, and that's working fine. The actual fault is on the what is called the AB5 board. It's this board with all the blue potentiometers on it, and this board takes care of quite a lot of measurements within the test set, and one of the main functions of this board as well, or one of the sub-functions of it, is to take that 110 kHz IF signal that's coming into it, and it demodulates the AM, FM or phase mod, which appertains to these buttons here. Now one of the tests that I've done, which correlates to these test failures here, which I'll show you, actually is down to not being able to demodulate the FM or phase mod signal coming in. So what we're doing is we're going to use the 2968 radio test set here, and what I'll do is I'll just show you on this bigger screen just so that it's better to see. And what we're going to do is we're going to select an RF signal. We're going to generate an RF signal, and we're going to produce a frequency of 300 megahertz at minus 20 dBm. We're going to have a mod signal on there as well at 5 kilohertz deviation, and we're then going to couple that signal in. We'll put this into transmit mode. We will connect the signal from the signal generator here, and as you can see, it's not receiving any mod, it's not demodulating. Turn the volume up, can't hear a thing. If I select AM, I can hear a bit of a carrier there trying to be detected. Phase mod nothing, FM nothing. So if I change the test set here to mod gen level, I'm going to set this to 60% mod for AM now. So we're changing from FM to AM, and now we're at 60% modulation. So we're now producing an AM signal into the test set, and if I select the AM button, we are actually getting something. I need to put the TX frequency in. 300 megahertz. There we are, look. So AM's working fine, it's reading 60%, you know, that's all functioning. The bar charts are working fine, the scope, you know. But if I go back to FM, and we then connect or set the mod gen level to say 5 kilohertz deviation, we're not getting anything at all. So that's the problem. The FM side isn't discriminator isn't working. Now I've read the service manual, and we've gone through various fault finding mechanisms to try and localise a fault to one board or the other, and as I said, I found the fault which I'm going to go into shortly. So what I've done, I've connected a spectrum analyzer up to the 110 kilohertz output on the Marconi radio test set. So on the rear of the test set down there, there is a lead plugged into the back on the 110 kilohertz IF signal that's coming out. So we needed to find out first of all whether the down conversion was working before we started looking into the discriminator, which is on a different board. So we were first of all going back to right to the basics of a down conversion side, is that working first, the IF side. So we set the spectrum analyzer up at an 110 kHz center frequency, and as you can see, if I switch the signal generator off, for example, the IF's gone. So that proves that the IF's there. As you can see there, we're also got 2 FM sidebands, which is applicable to the modulation that I'm applying. If I set the modulation to off on the signal generator, that we're generating 300 megahertz signal into the Marconi 2955, and it's giving 110 kilohertz output, which what we're seeing on the right now on the spectrum analyzer. So as you can see, when I introduce modulation, we can see the sideband. So that proves that the down conversion is working to 110 kilohertz, and that means that, yeah, we prove that the down conversion side's working. Well, with that in mind, the signal at 110 kilohertz is then passed to this board here, which is AB5, and this has got the discriminator circuitry on it for the AM and FM. And what happens is the 110 kilohertz signal that enters this board is split into 2, and there are 2 separate circuits on that board. One processes the AM signal for conversion and discrimination and demodulation of the AM signal. The other T section, if you like, is fed off to another circuit, again at 110 kilohertz input, which is the FM discriminator. And then the outputs of the FM discriminator and the phase modulator discriminator is on the top circuit, if you like, and on the bottom circuit is the AM discriminator, insofar as the diagram's concerned, which I'm going to show you in a moment. They're all fed the audio outputs after they've gone through amplification, filtering, and then they go into what is the discriminators themselves that demodulate the audio content from the 110 kHz IF. They're then fed into logic switches, audio switches, which are controlled by the logic circuitry. So when you select these different modes, the switches select the different audio paths leaving this board so that they can be displayed on the monitor. Now this is a circuit diagram of the board, AB5 board, and we've got on the left side here, we've got the 110 kilohertz input coming in, which is here, and as I said, it's split into 2 paths. One path goes upwards, which is the FM and phase mod side, and that then is fed through various comparators, as you can see here, high pass filters, limiter, and discriminator. And this is the FM discriminator chip here. So we have like 110 kHz IF going in, and then we have an audio signal coming out. And then the AM side, which is down here, is this circuitry, and then obviously it's fed off again. This is the other half of the diagram. The FM at the top, the audio signal is amplified and passed through to these audio switches for AM and for FM and phase mod, and then likewise for AM, the signal after it's been detected and the audio recovered is then fed out here. Now what I did, I went on to test point 2 here to see if we could recover any audio, and there isn't anything. So I started to work my way back, you know, backwards through the chain all the way back to the starting point. I mean, obviously if the AM and FM phase mod side didn't work at all, it might be worth looking at the supply rails to the board, and obviously, you know, there could be a supply issue there, and again, you know, that's a potential issue. But because AM was working, I didn't suspect a supply issue. We've got a DC switch here that when you select AM or FM, it obviously goes high for FM, and then we effectively get on the inverting, non-inverting inputs, we can get an inverting input change via this NPN transistor to ground. So this will bias this in a way where the FM discriminator would receive a signal then, and the AM mode, this switches off, so this then doesn't produce an output. but I couldn't get a signal basically anywhere along here, and I started to look a bit closely at things. I'm getting 110 kilohertz coming in here, but sod all coming out there audio wise. Anyway, I found the component which is actually causing the failure, which I'm going to show you very shortly. Again, if you watch the other repair video that I'll be putting on YouTube shortly, which is about an hour long, I actually found it's the same component, albeit on a different part of the system and on a different board and dealing with a different circuit, but it's the same component which has failed. This discriminator chip here wasn't getting a supply. And the reason being is this electrolytic capacitor here, this 220 microfarad at 16 volts, is short circuit, which is quite unusual for an electrolytic capacitor. They don't normally go short circuit. They either go totally open circuit and lose the capacitance basically, or the ESR value goes, you know, well out of spec. We've got a Zener diode here which gives a 4.7 volts supply via this resistor. So this is a potential divider basically with a Zener across the other side. This reservoir cap moves any transients that are on the supply line and then feeds that voltage then to the chip to supply it. And because this is short circuit, there's 0 volts on here. And I've actually removed this capacitor and measured it. Well, in circuit I measured it across the Zener diode and it's dead short. It's not even resisted, like 0.1 ohm. And it's the same value and component that was in the other video, which you'll see. But if you just bear with me a moment, I will switch off the test set, remove the board, and then I will show you the component itself and the measurement. So I'll just remove the board, I'll switch the test set off. And so this is the offending article, and we've got on here a discriminator chip, which is this chip here, IC103, and the supply that comes to the board goes via a Zener diode, obviously, to regulate the supply line to just below 5 volts, 4.7 volts, and that's a Zener diode there. Now, I'm just hoping it'll focus a bit better. There we are. Now, the Zener diode itself was basically short circuit when I measured it. So if I click my probes onto it, hopefully I can get onto it. Maybe not. But basically, if I just put my multimeter on the test set, and we go to a single, what is it? AF test. It's under on this. Okay. I'll put continuity on, and we've got the volume turned up. And if I just try and work my magic and touch some probes while I'm one-handed, basically onto here, and see whether we can get some connection. It's always difficult when you're working one-handed. There we are. So we've got a dead short across there, and what it is, it's the actual component which goes faulty is this electrolytic cap here, and here's the one that I removed from the other fault. It's the same. This capacitor here is what was removed from the other Marconi test set, which I've had for repair. And again, this, when you measure the capacitor, it's actually a complete short circuit, which I think these are a faulty batch that Marconi must have had. It's pinged off now. Here we are. I'll get it back. So I think that it's either a faulty batch or you know, because normally what happens is with electrolytics they just dry out and then they don't have any value. So right, I'll put that on ohms, and as you can see there, and I'll move this out of the way a bit, it's dead short. Now that's both ways, which it shouldn't be, obviously. Now what I've done before making this video regarding this particular fault that we're looking at today, I've actually removed this capacitor from the circuit and I measured it, and I've just put it back in for the purposes of showing you this video. But basically this capacitor is the same value and rating as that one I manufacture, and it's short circuit. Now there are two other capacitors on the board as well, which Smoother supplies for other parts of the circuit board, so I'm going to change these anyway because they're all the same value, 220 mic at 16 volts. But it's interesting how I've had two test sets now with the same problem, where the 16 volt 220 mic caps are you know, a short circuit. So anybody else gets this kind of fault or these weird problems, then I always recommend in just testing these caps, just put your multimeter across them, and if a short circuit, naturally you need replacing. But I've been quite lucky with the other fault that you'll see in the other video, because we had a supply rail that was coming from the power supply on the rear that only provided a very low current to start with. So when the transistor that switched on the circuit board on that other video, that switches the supply to an oscillator, a 200 megahertz oscillator, there's a capacitor across the supply rail, and this cap had gone short. Luckily it hadn't blown the transistor. All it meant, the transistor just got very hot, simply because the supply going to it, the current limit was on the power supply, and it prevented an avalanche of current. Otherwise it had destroyed the transistor as well. So I was quite lucky with the other fault, which you'll see in the other video. Likewise in this one, the resistor that supplies this is a 240 ohm resistor, which is one of these resistors here, and it hadn't burned out because of its value, and because it's only supplying a low current, we're quite lucky. So again, you know, a 16 volt 220 mic cap as a cause of this fault. Obviously when we replace this and put this, you know, board back in, it'll work fine, and you know, and I can show you that in another video. But the other video that I've done, I'll show you the whole process right the way from start to finish, which is an hour long. But this is just quite a quick fault find. So yes, thank you very much for watching. If you like the video, please subscribe, and obviously comment in the description below. Thank you now, bye bye.